And we're live. Awesome. Hello and welcome back to the UglyCode live stream. Today is December 3rd, 2024. So we're doing day 3 of the Advent of Code calendar 2024. Wait, did I say 2023 or 2024 earlier? Sorry. Advent of Code calendar 2024 for sure. Okay, so let's just dive right into it. Let's switch this over to, there we go, and there we go. Okay, so let's put that to the side. Okay, I think it's showing, yeah, it's showing everything. Okay, and let me move stuff here so that I can read it. There we go. Our computers are having issues, so I have no idea if we have any chief historians in stock. You're welcome to check the warehouse, though, says the mildly flustered shopkeeper at the North Pole Toboggan rental shop. The historians head out to take a look. The shopkeeper turns to you. Any chance you can see why our computers are having issues again? The computer appears to be trying to run a program, but its memory, your puzzle input, is corrupted. All of the instructions have been jumbled up. It seems like the goal of the program is just to multiply some numbers. It does that with instructions like mul xy, where x and y are each 1 to 3 digit numbers. For instance, mul 44, 46 multiplies 44 by 46 to get a result of 2024 or 2024. Oh, wait, what's going on here? Okay, no, it just doesn't like the bit rate. That should be fine. Okay, so where was I? Similarly, mul 123, 4 would multiply 123 by 4. Okay. However, because the program's memory has been corrupted, there are also many invalid characters that should be ignored, even if they look like part of a mul instruction. Sequences like mul 4 star and mul 6 comma 9 with an exclamation mark. So this one is almost valid, but it doesn't have mul. It doesn't start with mul before the function. Sorry, one sec. Or mul 2, 4, but with a bunch of spaces between it. So we got to make sure that it's mul with an opening bracket, 1 to 3 digits. So they mentioned 1 to 3 digits here, and down here, where was it? Here we go. They do talk about three digit numbers. So I think we can reasonably assume that it's only going to be 3, and they're not going to throw a 4 digit at us. And presumably that if we get a 4 digit, we're supposed to consider it invalid. But I guess we'll cross that bridge when it comes. If they do throw us a 4 digit number and we're supposed to consider it valid, then we'll figure that out. Okay, so here's an example where they've got a bunch of stuff and we don't care about any characters surrounding it other than mul 2, 4 in brackets, mul 5, 5. So you don't care about the do underscore not underscore, or this one where it ends with the wrong kind of bracket, or this one where it has the wrong kind of brackets in general on both sides. And yeah, this is just two of them, one after another, and it doesn't care about any of the other characters at all. So that's already sounding like a regex problem right there. Like we could, does it say we can assume there's, no, it doesn't. I don't think it says how many, only the 4 in this example, but okay, we'll see what the input looks like, because it doesn't necessarily, it doesn't say anything about that we can assume that there's only 4. So what we need to do is write a regular expression that will scan through any line of input and just look for mul bracket with 1 to 3 digits, comma 1 to 3 digits, and no other characters, and it'll just return all of those, and then we'll process each one individually. Yeah, just evaluate them and add it all up. Okay, so let's get our input. Okay, so let's upload this now. There we go. Okay, so let's take a look at what we've got here. So yeah, a bunch of garbage characters, and then mul, 3 digits. Here's another one. Here's another one. There's some other ones that look like mul, so we're gonna have to check and make sure that it's actually the string mul, but that's pretty easy to check for. I suspect that probably part 2 will expand on this and expect us to process more than just mul, but we'll see. Because the fact that it's formatted this way is already leading me to think that. And just taking a look to see if there's anything here that stands out as a gotcha. Yeah, no, it's mostly just 3 digits. I don't even see any that are like negatives. There's some that are badly formatted. I also don't see any that have capital numbers or... I mean, I don't think this would throw it off, but leading zeros, I don't think it really cares about that. I think if we pass that in through the int method, it would still handle that okay. But I don't even see any leading zeros. Just looking at this. Okay. Well, let's... Let's start in Python, and we'll read in the file and see what blocks we're dealing with here. If it's all one line, or actually, does it say that or no? Okay, maybe not. I think in this case we're just supposed to read everything in. Maybe it's multi-line, but I guess we'll figure that out. We're just supposed to read for all the mul instructions. Okay, so one thing we should actually probably check now then I think it's the RE module or library, but actually no, I think it is modules. Yeah, in Python it is module. But we'll just look up regex, and that brings us, there we go, the RE library. I think Python uses both words. Okay, so I think what we're looking for, first of all, is so we could use character classes and then just indicate digits, but easier than that would just be \d. I don't see it here, but \d should be a digit, and then we would add, let's see, we want it to be one through 3 digits specifically, so that would actually be this one here. One curly braces and then 1,3 for 1 to 3 repetitions. And I think, yeah, we'll probably also need to escape the round parentheses to make sure that it doesn't get confused with these parentheses. I think that should be good. Oh, the other thing that's really useful for for writing regexes is, the method that we came in here for, and then I'll show the thing that's really useful for actually writing regexes. I want to say we're looking for the probably find all. Search. Yeah, search is going to be the first location, so that's not it. No, this is just checking for a match. We want no, not full match, not split. Find all. Turn all non-overlapping matches of pattern in string. Yes, this sounds like the one that we want. Okay, so we'll come back to the documentation for re.findAll. But the other thing that I wanted to show here is regexer. So this is a very helpful website for writing and testing regex patterns. So actually here, I think we can even, where's the code for, or the input for today? This one. Here we go. Let's test that with regexer. Okay. So now in here we can put our pattern that we want. So let's try putting in mul, so the literal string mul, and we don't want it in brackets either, or parentheses, sorry. And we don't need a character class. We do want an escaped bracket. Let's take the word character out of there. Okay, so let's try, let's just try searching for the string mul, followed by a literal opening parentheses, or parenthesis, \d for a digit. Oh, it's even starting to work already. So \d for a numeric digit character. Curly brace 1,3 to make it match 1 to 3 of them. Comma as a literal comma character. And actually, yeah, now as I'm typing this, you can see why regexer is kind of handy to use for this. In addition to, it's also got that reference that we looked up, the documentation there, that's just the Python regular expression documentation. And there's a bunch of other helpful regular expression references, but this one also has the cheat sheet built in right there. So if you need to know what the different character classes are, or the anchors, or what the different parentheses what the different syntaxes for the parentheses are, or all the different types of quantifiers right there. So, but then also, as you're typing this stuff in, it also tells you down here what you're using. So let's finish this. For this part, we can just copy this because we want another set of 1 to 3 digits. And then a literal closing parenthesis. And there we go. That looks like that is working just fine. So sometimes it might take a few attempts to write a regex that does exactly what you want. So that's why this is really helpful to be able to just paste your text in here and it'll just evaluate it for you. You could also write your own test harness that'll do this for you, but or just pass it into a method in Python. That's easy enough too, but it's handy having access to it in a website. Okay, so let's copy that. And I think we're done with this for now. Let's bring it back over here to the problem. Okay, and bring my HDMI full screen. There we go. Okay. Actually, yeah, here first we will cat. Day3 input.txt. There we go. So that looks like it does have new lines in it. So we might have to, well, I don't know. We might be able to just read all of that. I don't think regex will really care if we hand it everything. So, one sec. Before we go into that, I just want to check and see. Yeah, f.read with nothing should read the whole file. Because this will give us iteration of lines, which we don't want. And read line will read it in chunks. But if we just call f.read, okay, so there we go. Now I can see what I'm doing here. Okay, do I need to declare anything beforehand? Yeah, let's say data. Just declare it as an empty string. And oh, actually, no, we should save a set of instructions. That's probably more useful. Because we're only going to need the data for, let's see, we're going to call f.read. Actually, yeah, it probably will be helpful to store the data, but also instructions. There we go. Now, with open day3 input.txt. Sorry, I'll sit closer to the mic so you can actually hear me properly. There. Okay, that's probably a little bit better. So with open day3 input as f. Okay, so now we want to call f.read to get everything. But we want to store it into data. So let's do data equals f.read. There we go. And then that way, when we can exit out of this block and everything will be stored in data, and we can have multiple attempts at processing it. Just in case I don't get the regex right on the first try. Oh, Why is there a shebang in there? Shebang user bin Perl. So I wonder if that'll come up later on. Searching for like Perl scripts in here somewhere. Anyway, sorry, let's not get distracted. Okay, so we've opened the file. We've read in the data. Yeah, let's just do that for now. Okay. Okay, that seems about right. Actually, let's check and see how big the file is, because I can confirm if that's right. Yep, 17,999 bytes. Okay. And then on the data, we want to, I need to import re for regular expressions. Okay. Now we wanted to do re.find all. And let's double check the parameters on that. Re.find all should be, we give it the pattern and the string. Okay, so the pattern will be the one that we wrote on regexer. Okay, I'm not going to be able to copy that across. I'm going to have to, can I write that somewhere where I can still see it? No, not really, but I can, it's simple enough I can remember that. Okay. The other thing, okay, so read out find all. So I need the pattern. So read up, find all. Now I think I can just do double quotes, but I might need to add in some slashes in here or something. But we'll try it without. Okay, so we got read out, find all, mul, backslash, open parenthesis, backslash d, curly brace, 1, 3, closing curly brace, comma, backslash d, curly brace, 1, 3, closing curly brace, backslash, closing parenthesis, double quote. Okay, so that should search for everything that's got a literal, the literal string mul followed by brackets and 1 to 3 digits in between. Yeah, that should be good. And then we need to pass it the data. Okay, and that should return a set. So let's just store that as, okay, and we're not inside of any indentation, so we have full scope here. So let's just declare something right now. Matches. And then let's check and see what we got. Whoa, okay, that's quite a bit. I think it worked. Okay, so now we need to iterate over all of those and parse them. And by parse, I mean call the int method on them. But, well, I guess there is a bit of parsing. We got to find the parts of it, although we can use the regex for that. But we need to essentially pattern match each of those strings and find the part that represents each number, and then take those numbers, convert them to actual integers instead of strings, multiply those, and add up the sum, and then we're done. So let's get on that. Oh, right, we called it instructions before. Although I guess matches makes more sense for the regex, but yeah, we can still use instructions later on. What we'll do is we will... actually, we don't really need to store these anywhere. But maybe we'll use it, maybe we won't. I don't know. I feel like we could probably just iterate over these, and for each one, we'll regex it, find the values, evaluate it, and we do need somewhere to... hang on, before we go into the for loop, we do need somewhere to store... So when we multiply the numbers, we'll need to store that, but we can declare that in our loop, that's fine. But we do need to store we do need to declare the sum. So we'll set it as 0 here, and then we can just add on to it as we go. Yeah, I think that should work. So for every match in matches, let's do... So for this one, I don't think we actually want re.findAll. I think we want... one of the ones that lets us match multiple positions. Let's double check and see which one we're looking for here. So with regular expressions, there's a bunch of okay, so the patterns generally work in a fairly consistent way, although there's a lot of flexibility and power in terms of what you can do with them. But there's also a bunch of different methods that allow you to do different things. So as we saw, this one returns you all instances of that pattern that show up in the string. Some of the other ones just return you the first one, or whether or not there is a match, or where it is in the string. So usually you want to take a look in here and make sure that you're using the right method. Okay, that's too far up. This is where the methods are. Okay, so we're looking for the one that takes in a pattern and finds us multiple variables in there. Actually, some of these will probably work anyway because they return a match object. Here, let's go over to regexer and let's test on this. I think what we want is a capture group. Yeah, so let's try putting a capture group around this. So in addition to our escaped parenthesis, our literal parenthesis characters, we also want to have some capture group parenthesis. And okay, so yeah, it likes that. It's not gonna, yeah, and it's seeing those as capture group 1 and 2. I don't know if it's actually gonna show us. Oh, it does actually show. Yeah, here we go. When you highlight it, it says group 1 and group 2, and it shows what the values, or what values it's capturing from that expression, or from that match, I guess is a better way of saying that. So that's exactly what we want to do. We'll just add in some parentheses, not brackets. Now, I don't think we need to use find all because we're just trying to, there is only one match. So let's also check and see if there's one that's good for just 0. Yeah, I think we want re.match. Because we were pretty much assured that we're matching at the beginning of the string because we've trimmed it down at this point. So that's the one that we want. Re.search is sorry. Re.search is better for if you don't know where in the string something is, but if you're trying to check and see if a string, like if a string or a set of strings matches a given format, then re.match is much better for that. And anything else I need to know about this? Okay, so we're passing in the pattern first and then the string, so just like with find all. We're gonna want to check and make sure that it's not none when we get a response. Although we've already pre-filtered this, so there shouldn't be any none anyway. Okay, so this would be relevant if we were treating, like if we were still processing the original data, which had new lines in it. But in this case, we've already broken it down into just a series of mul functions. So, yeah, let's just do re.match. Okay, and we want mul. Escape the parenthesis, the opening parenthesis, and then an actual parenthesis for our capture group, and then \d for our digit character, and then curly brace 1,3 to make it 1 to 3 digits, and then close off our capture group, comma, open up a new capture group with another parenthesis, \d curly brace 1,3 for 3 of them. So now that's our 2 numbers, and / closing parenthesis, and that's it. Let's close that string off with another double quote, and the thing that we're trying to search on is yeah, that shouldn't be a problem because I've declared a variable called match, but that is making me a bit nervous about naming my variables very close to things that exist in the language. But functions, sorry, one sec. Functions should be fine. But normally you want to be very careful about keywords specifically. But I don't think match is a keyword. Okay, so although I want to make sure that I'm not using the word matches again because because I've already used matches there. So let's call this one numbers. Yeah. Okay. Now I don't think we can do the splitting into multiple variables in this. We could try that later, but I don't think, well, I don't know that that'll work for sure in this, because I'm pretty sure re.match returns a match object, which we then have to look into, and it can have an arbitrary number of positions. So, but then again, it might work that it's able to. You know what? Let's try it. Because I don't have a whole bunch of indentation levels to repeat or anything, so I can just, yeah, let's try that. And then once we've extracted those numbers, let's print them. And if we don't get errors and if we actually get numbers, then Let's try that again. Nope. So because it's a, yeah, as I was saying, it returns a match object. So we actually have to store it as numbers. And then when we're dealing with a match number, let's just check, or when, sorry, a match object. Let's just check the documentation for the match object. Okay, no, that's not what I'm looking for. I'm pretty sure it's whatever the method that we need is. Here we go. Dot group. So, oh, actually, this is there. Match objects. Yeah, this is the section for match. I was just being impatient. If I look down a little bit, so this is the method here that we were looking for. Is when it returns a match, it breaks the match object into multiple different indices, I guess. Is probably the best way, or well, subgroups. Indexed subgroups is the best way to describe that. So you got group 0, which is everything. So the full match. But then you can also have 1 and 2 and 3, etc., matching all of your capture groups. So in this case, if you search for 2 words separated by a space, yeah, and it's looking for the first one. So it comes across Isaac Newton, and it sees, oh yeah, 2 words separated by a space, and so it returns the entire string Isaac Newton as group 0, because that matches the full pattern. But then it also includes 1 and 2, Isaac and Newton. Or, as it says right here, if you pass it multiple numbers, so if you say I want, let's say we've got 6 different positions, and you say I want 1, 3, and 5, it'll give you a tuple of those subgroups joined together. So, but what we care about is just accessing group 1 and 2, because group 0, actually here, we'll just take a look at it. If I say print %s, so first we'll plug in group 0, which should be mul, like the entire, the function, and then we'll say equals, we'll do, they're going to be strings at this point still, so although we could make them ints. Yeah, let's make them. Okay, well, we'll extract them first then. Num1 equals numbers dot group. Okay, but we want, that's going to be a string, so let's make it an int. And num2 equals int numbers.group 2. There we go. And then okay, so I was going to print them. %s, so that's going to print mul blah 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 equals no, %d, because it is a number now, times %d. Now this is not actually doing anything, this is just printing out the expression for us to see. But then also here, oh, I should have calculated the number too. Yes, because I will actually need the number. Okay, damn it. 1 sec. Let's do that now. Num3 equals num1 times num2. Okay, now we'll print the stuff. Print %s equals %d times %d equals %d, and then string interpolation, and then we pass it numbers dot group 0, so that'll be the full expression as a string. So like mul 189, 105, for example. Numbers at group 0, and we want to also pass it. So we need 3 more parameters. So the second one is num1. The third one is num2. And the fourth one is num3. And then we close off the tuple, and we close off the function call. So this line isn't strictly necessary. We've already got our answer from num3. What is necessary is that we need to, well, I'll show you. This next part, we need to store the value by adding it into our sum. So sum plus equals num3. That's what's really important right there. The print is just, well, I mean, it's important, but important in the sense of it gives me some visibility into what my code is doing and make sure it's working. But this here is what's going to actually get me my answer. Okay, so now let's run this, and that should spit out a bunch of expressions, and then at the very end I can ask it for the sum. There we go. That looks like it worked. Okay, now let's just ask it for what is the sum here. That's looking good. 155,955,228. Okay, let's try that. 155,955,228. Yay, we got our gold star. Okay, part 2. Sorry. Okay. As you scan through the corrupted memory, you notice that some of the conditional statements are also still intact. If you handle some of the uncorrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you'll need to handle. Yep, I called it. The do instruction enables future mul instructions. The don't instruction disables future mul instructions. Okay, so we're going to have something that toggles it on and off. I think we can still, we'll still be able to read it in. It's just we need to read in mul and do and don't, and then process through them. And as we're going through the whole list, we'll just have to flip a state to indicate whether or not we're processing them or not. So if we are enabled, then the muls count and they're added onto the sum. And if it's disabled, then we just don't process any muls. That seems pretty easy. Okay, but hang on, let's keep going. Only the most recent do or don't instruction applies. Okay, so I assume if there's multiple do's in a row, I mean, it would be the first one that applies, really. And then, I mean, that's kind of assuming that there will even be redundant do's and don'ts, but this makes sense that for any given mul instruction, you look at the last, was it a do or a don't? Where was I? Oh, this is also important because this was one of the things I was wondering. At the beginning of the program, mul instructions are enabled. So the initial state of our flag is yes. it's on, multiplication is enabled, so any instructions are processed. And it's not until we see our first don't that we turn that off. Okay. So in this example, we would process the 2, 4, and then we would flip into don't mode, and then we would ignore a bunch of valid instructions here, and then we would flip back into do. So I think it's probably easiest. We'll parse all of them. So when we run the regex, we will capture even these even these valid multiply instructions in here, but when we're iterating over it, we will see that there's a don't here, and that will just tell us to skip these. Now, if we were trying to deal with nested, like something like nested parentheses, that might be a bit more tricky, but so far they haven't thrown anything like that at us yet. Okay. This corrupted memory is similar to the example from before, but this time the mul 5.5 and mul 11.8 instructions are disabled because there is a don't instruction before them. The other mul instructions function normally, including the one at the end that gets re-enabled by a do instruction. Okay, so this time result is 48. Handle the new instructions. What do you get if you add up all the results? And it's the same input, but now we have to process some additional instructions. Okay, so let's go back over here and bring back our... So the data hasn't changed, so we can still use the data variable, but we need to rewrite our matches. Here, actually, am I able to, if I go far enough back, there we go. I need to import readline first. Oops. Okay, so there's our history. And which part do we care about? So we want to overwrite, we'll restart matches. Actually, no, we don't even need to do that because matches will get overwritten by regular expression. So yeah, let's not even do that. Although we do need to reset some. Yes. There we go. Okay, so matches equals... Actually, let's just bring the line back here because we mostly want that same expression. So matches equals re.findAll, except instead of mul, we need to put in an alternation that allows it to be mul. Oh, hang on. Because do and don't take any parameters. So we're probably better off putting an alternation around the whole thing. So it will either accept mul or, let's see here. Oh, actually, you know what? Let's test this in regexer. Okay. So if we just put in here, I'm pretty sure alternation is just, yeah, it's just the pipe character. So vertical line above the enter character, or the enter key. So that's our or slash alternation, different, but I guess, yeah, they kind of mean the same thing in this context. And then let's tell it to search for do. And an escaped set of parentheses, but that one we don't have to worry about putting any parameters in it. And another pipe, and don't. Now this one I'm pretty sure we'll have to escape the apostrophe because that's also, oh, maybe not. Okay, yeah, I guess apostrophe isn't special. I don't see it anywhere in the cheat sheet. It's like the one case where apostrophe isn't special. Okay, and then an escaped set of parentheses there. So that's going to search for any valid mul instructions and any valid do and don't instructions. And that looks like that's working just fine. So let's go type that over in the Raspberry Pi. So or do or don't. Okay, that should be good. Yeah, that's looking like I see do's in there. I see some don'ts in there. Okay, so now I think that worked. Is there anything else that I wanted in the history? Let's take a quick look at that. Actually, yes, I do still want the 4 match and matches. Okay. So let's bring that part back. So now we're going to oh, and we also, actually, before we get into our for loop, we do want, let's declare enabled equals true. There we go. Because we're going to need something to flip back and forth as we go through. So for match in matches, wait, do I need to? No, we're doing that right here. Okay. And then we're going to split that off into numbers equals re.match. Oh, hang on, no, this is where we need to process. Oh. I think Puppy wants to go outside. Okay. Well, let's park this here for now, and we'll do another stream in a few minutes. Okay.